Well, thanks a bunch, everyone, for having me at the Perl conference in the cloud this year. It's nice that the organizers have been able to transition so smoothly over to to doing this over Zoom. I attended last year in Pittsburgh, the EPSI, and definitely enjoyed it. So it's nice to, yes, smoothly in quotes. So it's been nice to be a part of this. So yeah, thanks for having me. Today I'll be talking about dependency freshness as a measure of keeping track of how our dependencies are out of date. So hi, I'm Scott, and I love to fix bugs and upgrade dependencies. And I love both of these activities so much that I started a company like focused on this effort. And for years, while I thought like dependencies were really important, and I would talk to a lot of clients about you need to upgrade them, and I would push people hard. I never pushed too hard because I figured people would upgrade when they were ready. And if I pushed too hard, then it would, beyond their comfort zone, things of that sort. And then there was like one particular event that happened that really got me thinking that maybe I should rethink that strategy. And that was this event. And when I dug into the details of this, like the Equifax breach was largely caused by there being one dependency that had been out of date for 2 months. And during those 2 months, there was a security vulnerability that was published and fixed. And two months within the 2-month window after the fix, the app was exploited, and tons of people all over the U.S. and many others had their information leaked. And I kind of found myself like rather frustrated about that. That I'm assuming a very well-meaning software team made a mistake like this, that where they didn't patch quickly enough, and because they had this dependency that they didn't update quickly enough, that all this data was leaked. And so that got me like really kind of thinking, why does that happen? Why does it, a common story that dependencies are the reason that applications get attacked? And why is it that systems are getting updated more frequently? And so dug in and thought of like, well, fear is a problem. Like, so, fear of upgrading, fear that upgrading will cause a breaking change, and that breaking change will introduce a bug, or maybe there's a bug in the new version. There's not just bug fixes in there. Maybe there's new bugs in there as well. So there's fear, and maybe there's also like some lore on the project of the last time that they did that. The last person who tried to upgrade too aggressively, nearly brought the system to its knees. Things of that sort. I've worked with a lot of teams that have had stories along those lines. There's also time. Keeping dependencies up to date is not easy. It takes time, and it takes a commitment, and that commitment's really real. And then priorities, like it's often less important, or seen as less important than other things that are on the project. Getting out features, fixing other bugs, responding to other user considerations and concerns. There's a lot of demand that's placed on a modern software team, and keeping dependencies up to date is often not one that they have a whole lot of time to devote to. And then the perceived difficulty, which it is rather hard. It is rather hard to keep things up to date, especially if the libraries that you're targeting are moving often, they're changing often. They might not be well supported for very long. It is a challenge to keep up with all that. And I think another thing is that it's a largely invisible problem. I think it's invisible to a lot of devs that work on teams. It's invisible to a lot of people who pay for the work on a lot of software projects. It's really invisible. So how can we make this a more visible problem? And that's where the dependency freshness metrics and measures come in. So dependency freshness was a measure that was coined by Joel Cox, a term coined by Joel Cox, to describe the quantification of how out of date dependencies are. Well, the idea being that the more out of date the more fresh your dependencies are, the closer to the more recent versions you are. And so we can start talking about freshness as something that we want to work towards, or like how fresh an application's code base is with respect to its dependencies. And I kind of like the metaphor of brushing your teeth. The goal is to have MINTY fresh software where we brush our teeth regularly. But that, you don't necessarily need to brush your teeth every 5 minutes. That's overkill. Find a good habit that works for you, like the right level of hygiene that makes sense for you. Some of us don't brush very well, and we don't often encounter negative consequences for that. But some of us who don't really brush at all, that's where having these out-of-date dependencies can start to have consequences. And the consequences really vary depending on whether or not you're a developer or whether or not you're the organization as the whole. So on the developer side, the more out-of-date a dependency is, typically the harder it is to work with. The docs for it, for the library, that version of the library can be harder to come by. It can be more difficult to work with as a result. There's usually new features that get introduced with newer versions of libraries that fix some of the problems and make things easy to work with. And support is often lacking with the older versions as well. So if there is a bug that you find, getting that bug fixed in the version that you're using, can be a challenge. It might be fixed in a later version, but upgrading to a later version is difficult. And that's where security fixes come into play as well. Now, on the organizational side, the productivity on the developer end is lessened. And that's really kind of all the items that we just talked about. Those are all items that relate to developer productivity. And there's also a significantly increased security risk. So the older and more popular the dependency you're using is, the larger target it paints for other people who are trying to do nefarious activity and want to break into applications and large applications en masse. If you're using a very popular dependency that's very out of date, and they're able to find a vulnerability in the version that you're using, especially if it's a version that's very widely used, then they could take advantage of that and attack a lot of apps at once. And that can lead to PR fallouts and loss of customer trust. So we need a way to make this problem more visible. We need some kind of diagnostic tool or maybe a metric. And that's where LibYear comes in. So LibYear has some benefits. It's simple, it's easy to measure, it's easy to compute. And I think like one of the best ways to see just how easy it is to compute is this little cartoon that's available at the libyear.com website. And it's clear here that, just quantifying down and talking about like how out of date the system is compared to other systems that the team manages, kind of giving a relative comparison for people to talk about like how more out of date or less out of date a project that people are working on is. So why should we use LibYear and why should we care about LibYear? So it's easy to compute. It distills dependency risk as a single number, which then makes it easy to communicate. And it provides even more value when graphed over time. So how do we measure LibYear manually? You can do it for a single package that your application is depending on, or your library is depending on. So you take the latest version and compute the release date of the latest version, and then you compute the release date for the version you're currently using, subtract the two, and the distance in years that you end up with is that package's LibYear. To get it for your entire project, you take all the dependencies that you're using and you add the LibYears up, and you get your entire project LibYear. How to measure with a tool. There are a variety of tools out there. This is one for the Python ecosystem. And this is what it looks like for a popular Python project, PySpider. And it just kind of, on the console outputs the number of years behind that library that project is based on all of the libraries that project is using. And then if you wanted to measure those changes over time, there's a project that I've been working on called Freshly. And it produces graphs. So you can actually graph the changes in LibYear over time. So here are the changes over time in that same project. And we can see here, oh, sorry, my daughter needs help with something. Can you wait a minute, sweetie, please? Please? Okay, sorry about that. And so here we see that the project's dependencies have changed over time, but then there's this really big spike like near the end of 2019. And you might find yourself wondering like, well, which of my dependencies is contributing to that spike? You can also graph the dependencies this way and actually see which dependency contributed the most to the LibYear spike. And here we can see that it wasn't just any one dependency that spiked around that time, it was a network effect. And the number of dependencies that all updated around the same time was rather significant. And so we can start to wonder like what might have happened in the Python ecosystem around this time that would have caused so many libraries to update all at the same time. And Python 2.7 was reached the end of its life at around this time. And so my guess, which I haven't had a chance to investigate to see if this is actually true, but my guess is that there were a lot of projects that decided to either drop support for Python 2.7 or maybe add support for Python 3, and that this caused a lot of projects to update around the same time. So let's take a look at another example with FeedBin. This is a Ruby on Rails project. And this is for an application. Again, these are both for applications. PySpider's an application and FeedBin's an application. And here we can see that this team has been paying off the dependencies over time since the start of the project. But we can kind of see that the general trend line is still up. They're really fighting the battle. And again, kind of being a little bit curious to see is there any one dependency that makes this difficult for them. And so we can look at it this way and like just see from the noise that like, no, it's probably that just it's a large network. It's an ecosystem that updates frequently. And so because that ecosystem is moving so rapidly, keeping up with it is going to be a challenge. So the graphs that I've shown you are developed with the tool that I've been working on, the open source tool called Freshly, which I'm working on Perl support. I was hoping to have Perl support done in time for this conference, but I did not get it done. There is a branch with it in progress, and welcome any involvement that people are interested in providing. But my mission is to create tools that clearly illustrate the financial risk of deferred software maintenance. And my vision is to have software systems that are self-healing and the out-of-date dependencies be a thing of the past. It is possible to craft CI/CD systems that detect when a dependency is updated, open a pull request for that, for updating that dependency, run the test suite and see if anything fails. And if it doesn't, and you have enough confidence in your test suite, then you can go ahead and deploy with it. And so that's kind of the self-healing aspect that I'm talking about. And I think that the goal will be that a tool like Freshly will eventually have less and less value because as teams start to adopt this mentality, then their graphs will just kind of be zero over time. So next steps and kind of ways to kind of further this idea of exploring dependency freshness. So I'd like to develop a metric that considers security risk. Right now, LibYear only looks at distance between the current version and the latest version. I think it would be interesting to also look at whether or not the current version has a security vulnerability that's published, and then what's the distance between that version and a version that doesn't have a known vulnerability, and also incorporate how long has that vulnerability been patched, and kind of take that into consideration. I think it would also be good to find ways to better compare LibYear across projects. I think LibYear, from what I can tell, seems to correlate very strongly with the number of dependencies that you have. So the more dependencies that you have, the higher LibYear is going to be. And then, could be like, standard deviations or other statistical measures that could be valuable to be looked at as well. And I think providing some guidance about what a good value is. Right now, at LibYear.com, the best guidance they provide is that a good value is an app that has a score of less than or equal to 10, and that the organization that created LibYear said that they often help teams with projects that have greater than 100 to kind of get to that point. So for those of you who are interested in getting involved, the GitHub project is here. Ways that you can help. We definitely need support for more metrics. I've got, there are a few metrics that are published in the paper that coin the term dependency freshness. That would be great to see those implemented and have the ability to graph those as well. And also develop some sort of metric for for computing security risk, and there's probably metrics out there that I'm not yet aware of that, adding support for those would be awesome as well. Adding more support for more ecosystems and dependency formats. Right now I'm working on Perl, Perl 5 support using the CPAN file. The Perl ecosystem has lots and lots of different ways to track dependencies. I'd like to add support for Raku. Those will all be great things to add, as well as many other language ecosystems as well. And I'd like it to be, if a project is using dependencies for multiple ecosystems, such as backend using one technology and the front end using another technology, that it's then able to compute this calculation across those ecosystems, across those dependency manifests. And then improve the quality of the graphs. I'm definitely not a visual designer, but would definitely like to see a way to improve that, to make them more easier to compute. But the thing that I would definitely want to leave you with, if you don't take anything else away from this talk, is that auto upgrading your dependencies is achievable. It's something that your organization can strive for. And if you have that within your means, please give it a try. Thank you. And I left, I think, a little bit of time for questions. If you'd like to get in touch after the talk, here is my contact info. So.
Yeah, you're good on time for questions. Sorry, I forgot to give you your warnings because I thought this was a 50-minute talk. But yeah, we could do about 8 minutes of questions.
Okay.
Feel free to unmute and ask a question. Dawn, you are using the wave icon. I don't know if you meant to raise your hand, but either way, you can unmute and ask.
And I'm monitoring chat and Slack as well, if anybody has questions that they want to post over there.
I was just trying to use the clap.
Ah, yes.
Hi, this is Fitz Elliott. Actually, I wanted to comment on something. I really like this idea. I'm currently working in a Python job, and one thing I miss from Perl is something I just pinged out in the Zoom chat, which is I love Perl. I really miss Perl's meta CPAN and CPAN list changes. When I was working on Perl projects, I had everything installed. I had all my virtual environments, but I also had all my dependencies installed in my global environment. And every day I run CPAN list changes to see what's changed. And honestly, Perl doesn't move that fast. So it's actually not that long a list to look through. And it's a good way to kind of keep an eye on anything important coming down the pike, anything that you think might kind of break stuff or security issues or things like that, because most Perl people write really good change logs. So.
Yeah, and I also have to say that, I've added support for Ruby, PHP, Python, and I'm working on Perl now. So I've gotten like a deep knowledge of different ecosystems and the way they manage dependencies. And Meta CPAN's API is really impressive. So I think it's something that this community can really be proud of. It is very impressive, and definitely a big pat on the back for everybody who works on that. It's definitely it's definitely clear. It's a lot of love has gone into that project and made it really, really, really nice.